Hi folks, so the question we're faced with here today guys is on the oblique planes chapter in your DCG workbook, and it is sheet number 11, True Shapes of Cut Solids. Okay, it's also on page 111 out of the book if you're looking for the exact page. So what we're faced with here is the prism shown has been cut by an oblique plane VTH, locate the traces of the oblique plane and produce a true shape of the cut surface. Okay, so we can see here we have kind of looking down here a plan. It's obviously a square based prism. We don't know obviously the exact height it was at, but what we can see in our elevation view, and I kind of just slightly shaded in there in red, is we can see the angle kind of roughly. Okay, not the exact angle, obviously we'd have to look at it from a different angle, but we can see where it has been cut by this oblique plane VTH. And obviously the plan view of it, then obviously we would still see a square, but obviously in this view here we can see it's obviously kind of cut at an angle. Okay, so what we have to do first of all is we have to locate the traces of the oblique plane. Now to do that, what we're going to do is on this surface here, looking at it, I've labelled 1, 2, 3, 4 in elevation, and the exact same in plan, 1, 2, 3 and 4. So point 1, 2, 3, 4, same down in plan. And what I could do is that oblique plane that is cutting it, okay, it's cutting it on that face there. So I know if I was to continue down maybe this edge here, 3, 4, and if I was to continue that down and extend it on until it hits the XY line, where it hits the XY line, that is actually a point on my horizontal trace. Okay, so that's what I'm actually going to do. We've done this in previous questions. So from 3 to 4, I'm just simply going to extend on that down there to the XY line. Where it hits the XY line, what we're going to do is we're going to project it down vertically, because somewhere down along that line there is the trace. And like I did here, do the exact same in my plan by extending the trace. This is what I'm going to call it, is 3, 4, so I'm extending the line 3, 4. It's not the trace just yet, but as you can see there, where it crosses, that is giving us, sorry there, it's just gone out of shot a little bit, so I'll bring it down a little bit there guys, apologies. But that is giving us a point that is on the horizontal trace right there. Okay, so if we did it for 3, 4, we can do it with another one. Okay, so one that maybe wouldn't be appropriate would be, we can see here the 3, 2. If I was to extend that down, it will come all the way over here, and then where it hits over here to come down, but we can see 3, 2 is going up into it. So that one's not really going to suit. You probably would work, but you're just making things hard for yourself. So we can either work with 2, 1 or 4, 1. So the one I'm actually going to use in this case now is, just thinking, would I use 2, 1? I'll actually use 4, 1. Okay, so extending out 4, 1, hits the XY line there, where it hits the XY line, sorry, move my board back in, where it hits the XY line, project it down, and then like we did in elevation, do the exact same in plan, extend out 4, 1, and there you have it. That is another point on the horizontal trace. So now I can actually draw in my trace. That is my trace where the oblique plane would cut through the horizontal plane, meaning I have the horizontal trace. So HT. Now at this point, it's very simple here. We can actually use one of the points, 1, 2, 3 or 4, to locate another trace. So I'm going to project up. I'm going to use number 3. This is the one that is the highest. So parallel to the horizontal trace, from 3, where it hits the XY line, project it up vertically, and then where 3 is in my elevation, project it across horizontally. And there you have it. That point right there is a point on my vertical trace. Okay, and what I'll do now, very simply, draw that in. Okay, this is stuff we have done. Vertical trace, right there. So, now I've got the oblique plane, the first part of the question, VTH. Now what they've asked us to do is they want us to get the true shape of this cut surface here. So obviously the true shape isn't this one here in plan, because we can see it's obviously at an angle. Okay, it's cut by the oblique plane, and we can't see the true shape of it here. So what we're going to do, there is a couple of methods you could do, okay, and the one we're going to do is by rebatment. Okay, so to do a rebatment, I'm going to put this in using green. I'm going to take a height randomly, doesn't matter where along the XY line, which I actually should have written in at the very start, just to write it in there. This is my XY line. So I'm going to take a height there randomly from the XY line, so from there to there. Okay, and what I'm going to do with that is rotate it about. Because that is a point on my vertical trace, and now what I'm going to do is project out perpendicular to my horizontal trace, and that will actually give me my oblique plane when it has been folded flat onto the ground. So a bit of rotation there, and slide this about, and here we go. It's after slicing through right there, and at that point there I have now found my vertical trace when it has been rebatted onto the ground. So that there, I'm going to call it V again, call it V1. Okay, right folks, so now what we want to do is we want to get the true shape of this surface here, 1, 2, 3, 4. Okay, so this surface that is cut by the oblique plane. So we have done this previously by rebatment, and what we're going to do is we're going to rebat it around, kind of like what we did here where we rebatted around and we went out perpendicular to the horizontal trace. We're going to do the same for the points 1, 2, 3 and 4. So having 3 already brought across, what I'll actually do is I will take my compass, put it here, and where 3 has been brought across and it hits my vertical trace, I'm going to rebat that around. Okay, you don't always have to put in the whole arc, you do not always have to do that, you could just mark it down here. I'm just showing you where it's coming from, and from there then what I'm going to do is come out parallel to my horizontal trace. So parallel to the horizontal trace, I'm just thinking beat out around here, yeah. So about there, and then perpendicular to the horizontal trace, I'm getting number 3 now, so from there, just slips there a little bit. There we go. So perpendicular to the horizontal trace, from 3, check that out, and there I have my point 3 found for my true shape. So exact same method then for 1, 2 and 4. Okay, so I'm going to bring all of those across straight away. So for 1, get to the cross, for 4, same, and for 2. Okay, and the exact same then with them, I'm going to rebat them around. So start with number 2. Okay, do the same for number 4, save me a bit of time. And then finally for number 1, it's a lot smaller. I'd actually have to change just the distance on my compass. There we have it, and I'm actually just going to do it in that direction. There we have it. Okay, so I'm going to find each of these individually. So start with number 1. Start off by projecting parallel, and I know number 1 is down here, so then I'll go perpendicular for number 1, and I found point 1, which is there. I could do the same for number 2, I think it is, yeah, so just make sure I have the right one. Yeah, number 2 is here, just follow it around, and 2 is going to be not too far off there, yep. So there's number 2, and finally last one, number 4. So project down parallel to the horizontal trace, and then from 4 where it is in plan, perpendicular. And there you have it, that's number 4, and connect them all up. So 1 to 2 to 3 to 4, and then 4 obviously back to 1. There we have it. That is the true shape there found in our by rebatment. Okay. So another way, guys, actually just on that to get the actual true shape. not by rebatment, okay, but another way we could actually do it. Technically I suppose it is by rebatment, okay, but instead of actually projecting these all the way around and then going parallel, another way you could do it, okay, and I'm just going to put this in green, okay. So let's say I was to do it for the point number 4, okay, so I'm going to do it for point number 4. So from the point number 4 I'm going to go parallel to the horizontal trace up to the XY line. I'll put this in green, go over to the marker afterwards, and where it hits the XY line I'm now going to project perpendicular to the horizontal trace, okay. So like I've previously done, so I went parallel to the horizontal trace first of all, where it hits the XY line, perpendicular, and what you'll actually find is it's going to hit my trace, and you can see where it hits here now, okay, and that is in the exact same position as when 4 was rebatted around, okay. So what we did was we essentially went parallel to the horizontal trace where it hits the XY line, and we went perpendicular to the horizontal trace, and then where it hits here rebatted around, okay. So that's another way you could do it, okay. I'm actually just going to put that in with a marker, okay, just to highlight it a little bit further, just showing you that there is different methods and they all work. Just going to put it in kind of as a hatched line. And then down to here. And obviously then 4 was coming out perpendicular from that as well. Okay, so literally went up parallel to the horizontal trace and then perpendicular, which is the angle there, and then where it hits here, okay, on the vertical trace when it has been rebatted down flat, we went parallel to against the horizontal trace and then perpendicular, okay. So you can actually see it's essentially making a rectangle, okay. That's just another way that you could find the points rather than projecting them across, rotating them around and then bringing it down. It's the exact same thing, okay. We're just doing it another way, okay. Hope you found that helpful, guys. That is the first question complete there on that page. We're going to move over to the second question over here now on the right. Okay. Right, folks. So in this question, like the last question, we're going to have to get the true shape of the cut surface, but also we're going to actually have to complete the projections up here of the elevation and the end elevation view of this object, which they have shown to us here in our plan view. Okay. On that then, guys, basically we can see they've also given us, in this question, they have given us the oblique plane VTH, okay? So just going to read the question there. It says, question 2, given are the partial projections of a hexagonal prism cut by an oblique plane VTH. Complete the elevation and end view to locate the cut surface, and then project the true shape of the cut surface, okay? So what we're going to start off with, guys, before we get on to the second part of produce the true shape, we're going to complete the elevation and end view. So I'm just going to zoom in there a little bit, and you can see here we kind of have a faded out elevation and a faded out end view, okay? So simple orthographic, might have to use my 45-degree line here to project up some of my points. So I'm going to just have that set up again, okay, to transfer any width side that I might need. And starting off, always I would label, and we want to see how many faces it's actually cut on. So just thinking there, I'm going to start with this one here, and we're going to call it number 1. It's cut here. Number 2, cut here. Number 3, cut here. Number 4, 5, and it's cut here, yeah, as well. And I'm going to call that point number 6. Okay. So what I have to find up here in my elevation view is points 1, 2, 3, 4, 5, 6. And once I find them up here, I'm also going to find them over here. Okay. So starting off with number 1, some of these will be a little bit different. They won't all work the exact same way. But starting off with number 1, I'm going to use the point location method. Okay, just going parallel to the horizontal trace up vertical, and where it hits the vertical trace across horizontal. So I know point number 1 is along this face here. It's at the front of it, okay? And I think it's actually coming up. It's on the top edge. So I think it's going to be somewhere over here, okay? So we're going to project parallel for number 1. I think 6 would actually be the same. I'm just thinking then, but 6 is going to be down. Is it over here or it's down here? I think it's going to be down low actually. So we can see with 1 it's going to be up high, whereas 6 is down low. Okay, so I might as well just do the 2 of them at the same time. Okay, and where the 2 of them hit the XY line, I'm going to project up to the vertical trace. Do the same with this one. That one obviously doesn't go up as high. And then find them. So 6 is going to be here, right there, and 1 is going to be there. So just have them found. So that's point number 1. Point number 6. So we'll move on to number 2. I can see here that 2 is on the top and it's right on the edge. Okay, so that's important. So I think 2 is actually going to work out as being over here. So I can simply, with number 2, I can actually just by, okay, I could actually go parallel to the horizontal trace, project up, but we'll actually see that it ends out up here anyway. So I know 2 is just up here vertically. So I can mark that there. That's number 2. And I know 2 is over here then, I'd imagine, right there as well. So that's number 2. That's found on my end elevation. Okay, if I was to bring that across, it should all line up, provided my set squares are accurate. Let's see here now. Yeah, that's okay, and you can see there it's lining up. Okay, so I'm happy with that. And now we're going to move on to number 3. We can see trees along the back edge there, so nice and easy. Trees up here as well. So there's number 3. Once again, just to prove it, project it up. But what I will do with number 3 is I'm going to project it across to my end view. I know I haven't found 1 or 6 yet over there, but I will. It's on the top face. We can see the top faces here as we look down on top of it. So it's up here somewhere. So once I project it up, you can find that. So there's number 3. I'll come back now and I'll find number 1 and 6 actually. So 1 was over here. I'm going to imagine, yeah. And just to prove it, I could project that across. And then where it hits my 45-degree line, project it up. Hopefully they all match up, yeah. Happy with that. So that's number 1. I'll do the exact same with number 6, even though I know it's at the opposite side. 6 is going to be right there. And just to prove it, I'll project that across. And hopefully, once again, these will match up. Yep, happy with that. There's number 6 matching up. So I'm accurate so far. Now the one I have to find next is number 4, and I think number 4 is going to be along here. Okay, so it's on the same, it's out here where 3 is as well. Okay, but I don't know where it is here. It'll be hard to find the height of it there, so I could use point location, or another way I could do it is just project up here and then cross. So there's 2 ways you could actually do it. So for number 4, just make sure, yeah, it says it's going down, so just want to be sure that. So for number 4, I can project across there. I know it's on the back face there. So that's number 4 there. Should be number 4 right there. And then once I have it there in my end view, there's number 4 there. But just to prove it, I could do it with point location, so parallel to the horizontal trace. Just showing you there's many ways. So for number 4, could have gone parallel. You can see there from number 4, parallel like that. Where it hits horizontal trace, or sorry, where it hits the XY line, project it up. And as you can see there, then they should, depending on my accuracy, and I'm not too far off yet. So there we go, matches up perfect. Okay, so we're on the right track. 1, 2, 3, 4, and the last one now we have to find is number 5. And looking at number 5, I think this is actually on the outside edge. I think it's right here at this point. So right there. Because as you can see, it's right out to where it kind of goes out and then back to in. So we can see that it's actually, if you look at the opposite side here where it comes to a sharp edge, that's actually a point that's on the edge. Okay. So for number 5, it is projected straight up. And that is where number 5 will be, right there. Okay, and I have it over here as well. And just to prove it, once again, we could do parallel, no, because it'll be on the same height. No, so that's actually fine there. Everything's lining up there. I'm happy with that. So now what I'm actually going to do is I'm going to heavy in my detail. So okay, so I'm going to heavy in my cut surface. So I know 1 connects to 2, 2 to 3, and so on. So 1 to 2. 2 to 3. Try to make sure it's exactly horizontal. 3 to 4. 4 to 5. 5 to 6. And then 6 up to 1. So that's kind of the cut surface there. And heavy that a little bit in there. Now I'll heavy this on the way down, and this will probably start to become a little bit more clear. And 4 or 5 into that. Do I have an edge there? No, I don't. 6 is going down, so I do have an edge at the back here, okay, which is along the middle. So I'm moving there a little bit. So hidden detail edge here. Hidden detail edge there. 5 was just a point, so that's going in there. Yeah, I'm happy with that because there's no edge here. Okay, just making sure now as I'm working through the drawing. Face is going down. Yeah, no, that's all good. Alright, so what we're going to do now, top surface. Yeah, okay, so what we're going to do now is the exact same over here. So it's 1 to 2 and so on. 1 to 2. 2 to 3. 3 to 4. See the top kind of bit of it is cut off there at an angle. Okay. 3 connects down to 4. 4 connects down to 5. 5 connects to 6. So it does. And 6 is at the front, but that actually continues on down to the ground. But 6 is going to connect across to 1. Because that's where we have the cut surface, and I know then that 1 continues on, so I'll actually just heavy in that edge the whole way there. I'll heavy in this bit down here because we do have a front face here as well. Okay, so that's actually the cut surface in there. So I'm just going to colour that in with a little bit of red there, so I'm going to speed up the video. Right folks, so as you can see there guys, just kind of quickly shaded in that area there. One little bit of detail I did forget, and I made one mistake, and this is what I was wondering about a minute ago. That edge there should have been heavy. I should have realised obviously because we have a face here, okay, as it goes up to 4, that face is still there because it hasn't been cut by this oblique plane. Oblique plane cuts it here, so that edge there is an edge there, okay, where it is heavy. In this view, because obviously even though 5 goes back in this view we would see it, okay. So now the next part of this question guys was, it said produce a true shape of the cut surface, okay. So what we're going to do first of all is we are going to rabat it down. So I'm just going to zoom out there a little bit, and what we're going to do is we're going to rabat down, okay, this plane, okay, so the oblique plane. So we're going to get the vertical trace down here, okay. So like we did in the previous question, we're going to take a height, okay, height to give us a point on the vertical trace anywhere. It doesn't matter where you take it. In this case I'll actually just take one of the ones that I've already got there. So I'm going to take this one, so just going to heavy over it in green there as you can see, and perpendicular then to the horizontal trace I'm going to project down. Perpendicular to the horizontal trace. Not sure exactly how far I need it there just yet. And then with my compass to where it hits the vertical trace, rabat it around. You can see it's gone over to the other page, doesn't matter, just kept it neat. And look, all I really needed was this point here, okay. And what we've found there now is the vertical trace when it has been rabated down onto the ground, onto the horizontal plane. So there's our V1, okay. And now what we have to do is we have to get the true shape of this cut surface 1, 2, 3, 4, 5, 6. So like the last question, I'll just show you one point method here, but what I'm actually going to do is the alternative method that I went over at the end of the last question. So in the case of finding point number 1, you can see here I've already transferred across. So just doing the old method, okay, and not the alternative method. So for where point 1 is, I could rabat that around. Could rabat it around, whichever one you're most comfortable with. If you like this one, stick with this one if it's the one that makes more sense to you. And then parallel to the horizontal, where it hits that vertical trace on the ground, we're going to go parallel to the horizontal trace. So don't think I have to go too far here. Okay, from there, and then where 1 is in my plan view, project it out perpendicular. As you can see there, I have now found point number 1, right there. But what I'm going to do now is for points 2, 3, 4, 5 and 6, I am actually going to use the other method that I showed you at the end of the last question. You can kind of still see it here where I kind of use this little rectangular box, okay? So starting with number 2. I'm going to go parallel to the horizontal trace. Starting with number 2. Where it hits this point here, what we're going to do is we're going to go perpendicular to the horizontal trace where it hits the XY line, where it hits my vertical trace now, project it down parallel to the horizontal trace, and as you can see there, then from number 2 here, and there we have it. Okay, I do find that method a little bit quicker, okay, but because the kind of method that we're doing here is rabatment, the one that kind of people usually like to stick with is this original first one, but it's just good to know both. So if that's number 2, do the exact same now for number 3, and hopefully that one actually worked out fine for number 3, so it stays in the same place. And number 3 is going to be just out here, so it's just going to be a touch further out. Okay, so that's where number 3 is. Do the same for number 4. So as you can see there, number 4 is on that one. That one's already there. It actually worked out fine. So number 4 followed up, hits here, down to here, and then project out parallel to the horizontal trace, and then perpendicular from where it is in plan. So there's our number 4. And now we have to find number 5 and 6. So 5 parallel to the horizontal trace to hit the XY line, then perpendicular. You can see here it's kind of going around, kind of like in a map in a circle. It's going to be down here somewhere. There's number 5. Finally, last one, number 6. And that's actually already gone parallel because I did it at the very start. Now from there, it's actually going to be a lot closer. So from here, perpendicular, you can see where it's hitting here on the vertical trace. And then number 6 is there. There you have it. That there is number 6. So very simple at this stage now, just connect them all up. 1 to 2, 2 to 3 and so on. There you have it, folks. That there is the true shape, so just write that in there. That there is the true shape of this cut surface here on this hexagonal prism. Okay, and that there was done by using just the alternative method there, guys. Okay, slightly different method from the one that we did here on the previous question. Okay, I still did one example with the point number 1 where I rabated it around, where it hits the vertical trace, projects down parallel to the horizontal trace, and then perpendicular to the horizontal trace. And other methods then, obviously for number 2, we went parallel here to where it hits the XY line. And you have to remember the XY line is the wall, so it's like the wall is coming up out of the page, so that's why then we were able to project out perpendicular, give us the mark out here, project it out then. Okay, look, you don't have to do it that way, guys. If you found the original method that we have practiced previously where we just rabatted around and you want to stick with that, that is absolutely fine. That is just another alternative method that you could use as well. Both work fine. If you don't want to get confused, stick with the one that you know, okay? But it's good to know both. Alright guys, hope you found that helpful. That is the 2 questions completed there. Okay.